first of all, I want to thank the organizers and Mario for inviting me to this exciting conference. It's so moving to be here on the occasion of the Mario's retirement as a academy dean of the study philosopher. We both sure that Mario actually during many years, and so that I will selfishly benefit, from Mario's comments and expressions that have been having for many years, decades now. So thank you very much. And today I will speak about a standard classical problem that any scientific realist has to face, namely the stability of reference of theoretical terms and to changes of theories. Now, to start, I would like to okay. So some time ago, I wrote a paper where I criticized Putnam's no-reference argument, and a few years ago, Mario, after many discussions between us, wrote a paper criticizing my criticism, my critique of Putnam's argument. And I remember with great pleasure the discussions we had at that time, and Mario and I are both scientific realists, but whereas Mario defends realism with explanationist arguments, I am trying to provide an interpretive defense of scientific realism. I'll say a few words about that. So I will first present the epistemological scientific realism I favor, then make some philosophy of language reminders, then speak about goal, reference to the word goal, and stability of reference in the case of the electron. That's a historical example I'll discuss extensively and then take a conclusion. What I mean by epistemological scientific realism is the following. So I think that we have strong, cogent arguments that give us more reasons to believe, rather than suspending our judgment or believing the contrary. We have more reasons to believe in the existence of entities, and I take entities to be instantiated properties, and to be bundles properties, as many empiricists defend. So I think that there is a good case that we can make in favor of the existence of properties. And the scientific realist claims that we have good arguments for belief in properties which are not directly observed, but which are detected. Let's say a few words about that too. And in the truth of selected statements about these not directly observed entities. And we have better reasons to believe the existence of a detectable property if and only if it has been repeatedly measured by independent methods whose reliability is grounded on empirically deductively confirmed causal connections between this instantiated detectable property and directly observed properties, and the measurements are concordant. So this is a bit compact. First of all, as I show here, but I didn't did it, a detectable property is a property which is observable in this. For example, velocity. I take velocity to be an observable property, visible. But of course, we cannot observe directly very small or very large velocities. Nevertheless, I think that we can detect those very large velocities because there is some overlapping between domains, empirical domains, which high velocities are immediately observed, and the lower part of the very high velocities. And then step by step, we can check the reliability of instruments, which allow us to detect very high velocity. It's called the Galileo strategy that has been developed by, among others, Philip Pitcher. So that's very important because I'm trying to provide an empiricist as scientific field, and therefore the instruments that allow us to substantiate the claim that there are causal connections between what is detected and what we immediately observe. I mean, for instance, are must be verified, and I take causality in the legal sense. Right? Most empiricists do. So the further condition is that there are different methods that have been experimental methods, observational methods that have been inductively confirmed and that are independent and also that give concordant measurements. So there is a condition also of invariance. So this is very quick. I've developed this in the papers, including in Italy, and some of you have heard already this, and so I decided not to speak one more time about this. But summarizing, there are 4 conditions for having good reasons to believe in the existence of some not directly observed detected properties. Those 4 conditions are that the properties are observable in principle, in the sense I explained about velocity, that we have inductively confirmed causal links between immediately observed properties and other immediately observed properties which overlap some domains of properties which are not immediately observed, invariance of the measurement results, and of course that we have means to measure precisely the relevant properties. Now, a standard objection to epistemological scientific realism in this sense is that through the history of science, there has been many changes and profound changes in theories. And so we have to show, the scientific realist has to show that it is more reasonable to believe the stability of reference notation of certain theoretical terms, whether the vocabulary changes or not, through the evolution of science. So as first sight, there is a problem. Because when we look at the history of science, we realize rather quickly that atoms, genes, oxygen, electrons, etc., of our current theories are endowed with properties which are very different from those attributed by earlier theories, and properties that are even incompatible with properties attributed to these entities by previous theories. Now, how to overcome this problem? Well, let me remind you rather quickly, because I suspect many of you, if not all of you, are familiar with these elements in philosophy of language. Let's start with Frege, who made a famous distinction between meaning, sin, and reference, Deutung. So the expressions morning star, so there are quote unquote, and evening star. They have different meanings, but they refer to the same entity, namely the planet Venus. So morning star and evening star are descriptions, different descriptions, and different ways of referring to the same thing. So the meanings of the terms atom, I think, have changed very much with new scientific discoveries, but and also the descriptions of entities to which these terms are supposed to refer have been modified and include terms referring to new properties. So the way of referring to the entities that it knows has changed, but I think, and that's what I will try to defend, despite the changes of descriptions, some descriptions of the entities in the history of science, we can make a case in favor of the stability of reference, stability of reference. And this allows to counter higher arguments and these objections of incommensurability. So to reply to the incommensurability objection, we have to show that the reference of mutation of certain terms remains stable, invariant, through changes of meaning. Because the comparison of theories, so incommensurability creates problems for comparing the merits of competing theories, but the comparison of theories requires that those theories or theories talk about the same things, or at least some of them. Even these theories may attribute different properties to them. So scientists who discuss the merits of different theories must speak about the same things, and they disagree about which properties they should attribute to the same entities. Without referential invariance, scientists debating the merits of competing theories engage in the dialogues with them. Now, traditionally, there are two conceptions of reference: descriptivist and causative. So, rather quickly, descriptivists like Reagan and Russell say that the reference of a name, start with the descriptions of names, is uniquely fixed by the description. And the description consists in mentioning some of the properties it possesses. For example, names, the term Albert, the King Albert II, or Albert II, is described as the sixth king of the Belgians. And this description identifies unambiguously a specific person, Albert II, without quotes. Now, the problem is this: if no entity has the properties referred to in the description of the name, that is, if no entity satisfies, realizes the description, then the name has no reference. So if the description changes, and then new predicates, and those predicates happen to denote property which was possessed by the intended reference, then the description is not capable of identifying the reference. So according to this descriptive theory, if the description changes, then the identification and the stability of the reference dies. Okay, because the new description, the history of science, new description could add a new property, mention a new property, and a new predicate, and the entity supposed to be referred to doesn't have that new property, and then the description has no reference. So there is a difficulty for the identification of the same reference. But before I discuss this, let's remind you the causal. By Brian Marcus is a causal theory of reference. So they say by extension, proper names get denote a reference without a description, the baby types John, for example, or even when the description is false. So the reference is fixed by an act of baptism, by which the person saying the name has the intention to denote a given entity by this name, and the name and its reference used by the baptizer is transmitted to other speakers through relations between them, that is by interaction, and these interactions are closure chains. That's why it's called the closure theory of reference. And it's Diego Marconi, who's an Italian philosopher of language, he proposed to call this conception of reference to the causal intentional conception. I adopt a certain version of this cryptivism. And let's remark first that according to Kripke, naming a necessity, reference can also be fixed by description. For example, and this is an example which is in Kripke's book, the act of baptism of the planet described as the cause of the perturbation of Uranus' orbit, named Neptune, before it was observed in telescopes, was achieved by a causal description, because it's described, Neptune is described as the cause of the perturbations of Uranus' orbit. And this causal description, in this case, does not characterize the reference externally as being a cause. It also mentions an internal property of the qualitative referent, that is planets. So if the act of baptism is made by means of the description as a planet, which is the cause of the perturbation of Uranus and Neptune, if it is the case, if the cause of the disturbance had not been a planet, Neptune would have no denotation. So this will come back in the rest of my talk. To secure the stability of reference, it would be a good idea to mention in the description of a reference only external properties, not internal. And I'll go back to this. So a description, of course, contains predicative terms, and these terms must also have a reference. The reference of a predicate can be fixed by a description with other predicative terms, but to avoid the regression ad infinitum, some predicates must have their reference fixed by ostension. So I propose a kind of mixing, because ostension occurs prominently in the causal account. I propose a descriptivist theory of reference, in which some predicates, basic predicates observed, predicates refer to observed properties of things. A successful reference for predicates is based on the ostension of observed properties of life. We have this regression, the risk we have regression. And also, I follow David Lewis and Robert Nolan in advocating a less restrictive version of this descriptivism. Remember, according to the strict descriptivism, if there is no reference to the description, if there is no entity having all the properties mentioned by the predicate in the description, then there is no reference. There is no reference fixed. But David Lewis, he takes up an example by Kripke of Jack the Ripper. So Jack the Ripper is described as the cause of the death and the murderer of is the murderer supposed to be the murderer of 5 women. And if we add victims to GR's description that he didn't kill, no entity strictly satisfied the description, but partially does. So strictly, there is no entity That's satisfied the description. If the description is mentioned a woman that Jack the Ripper did not actually kill, then this description fails to identify a specific person, a specific denotation. Okay. So according to Lewis, an entity can be an imperfect satisfier, or the best imperfect realizer among candidates that partially satisfy the description. And this account permits to account that rather mundane fact that we can learn something new about previously identified entities and correct errors. So identify Marius car, for example, and I believe that Marius car is red. And then okay, focus on Marius car, and it's not red. I made a mistake about the same thing. We identify and start Marius car. So I say if I describe the car and I say it's red, then Marius car partially satisfied the description. Okay. But scientific realists, as you know, focus not on proper names, but on the reference of terms, atom, electron, gene, that refer to natural species or natural kinds. It is better terminology. But I don't believe in natural kinds, but I believe in the existence of properties. So according to me, natural kinds are bundles of associated properties, and we determine if an entity belongs to a natural kind only if it has the properties mentioned in the description of this kind. So describing a natural kind, so natural kind, consists in mentioning the associated properties that determine that an entity consisting of those properties belongs to a natural kind. So to identify an electron and say that it's a particle which has a specific value of mass and specific value of charge, electric charge, for example. Okay. So I describe entities which share specific properties and which are usually taken together to constitute a natural kind. Like many empiricists, people can make a strong case in favor of the independent existence or the additional existence of natural kinds. Okay, now let's take the example of gold, and maybe I will very quickly on that because I don't have time. Well, so if you take gold to be described as the shiny yellow metal, that's the description that I described gold at the beginning. But some explorers call gold another substance, later called iron pyrite, which also has the properties of being yellow and shiny. And this was Alvaro de Mendaña, who, when he came to the some archipelago near New Guinea, he called them this archipelago the Solomon Islands, after the legendary gold mines of the king. Then these explorers quickly realized that what their first gold wasn't the family gold because the form is fragile and has an unpleasant smell. So they call it then false gold, fool's gold. So you have new words to designate the same reference, but only the same thing, obviously. So scientific realists are interested in natural kinds that are undoubtedly observed and whose references are specified by forced description. And the case of the gold, the first was a natural kind, gold, as the Spanish explorers coming to the Solomon Islands. And then what they did after further observation, they made what Robert Nolan calls a denotational refinement. So the kinds identified by the explorers were divided into gas, genuine gold and false gold. The difference between materials can have 5 to 10 with that, which basically creates elements which contain only one proton and then nucleus. But there are also isotopes, and then so you make the denotational refinement. So the natural kind hydrogen as subkinds. But this is not something that will play an important role in the discussion of the electron further down. So I disagree here with Kripke. When they arrived in the Solomon Islands, the explorers, Spanish, did indeed see gold. According to the initial description, so gold. What they saw was identified by this initial description. But discovery of new properties led to make a distinction between genuine gold and false gold, and then introduce a relation refinement. So according to the new description, the explorers did not see genuine gold. The natural gold, according to the initial description, comprised 2 subspecies, genuine gold and iron. Pyrite, pyrite. Iron. It's in the same way as a natural kind hydrogen within 3 subspecies. Okay. Now let's look at the stability of reference in the case of electron, and here I will be very much inspired by Robert Nolan's beautiful paper. So that well known. I really recommend that paper. So Nolan applies the causal descriptivist conception of reference to kind terms. And he claims, Nolan claims, that the cause of what Brugger, scientist, first observed in electric discharge tubes is the same as what we call today stream of electrons. So what is the experiment? So we have a glass tube filled with an extremely rarefied gas and equipped with an anode and a point-like magnetic cathode, between which a high electrical potential is set up. Under precise and repeatable conditions, Brugger observed luminous rays emanating from the cathode and greenish glows on the walls of the tube. So the something that produces those effects can be identified and described as the cause of the rays of the greenish glow under precisely described and repeatable experimental conditions, because the referent is fixed. Simply by speaking of the cause of what is seen in these electric discharge tubes. Okay? So Brugger called the rays that were shot off the cathode the rays of magnetic light, because unlike ordinary light, they are sensitive to magnetic fields and also electric fields. So the causal description only refers to extrinsic properties of the cause and doesn't mention any intrinsic properties. So as Noah says, rigorous investigations provide sufficient information to yield identifying conditions for an entity of some kind, which was what Brugger observed, even though no intrinsic property of the kind was known of the entity, but only its extrinsic properties in specified experimental setups. Specified experimental setups that could be described in terms of in terms of predicates, and predicates which refer to observed immediately and directly observed from these discharge tubes. So that's the point, to ensure the stability of reference of the something in those discharge tubes. Well, you just speak about the cause. some observed effects. Okay, and then you identify reference. Okay. But there could have been several causes. There could have been several subspecies, like in the case of hydrogen, but turned out that's not the case. So what is recommended to fix and to ensure again the stability of the dilatation is to avoid in the description hypothetical explanatory internal properties. Internal properties of the cause of the observed effects. Because if you mention hypothetical properties which have an explanatory role, well, then you have a description, and the description will be wrong. It's fair to identify the desired reference. So NOLA recommends restricting descriptions to what we can observe or experimentally determine. So restricted, the denotation fixing description is less likely to pick out nothing or to carry excess explanatory baggage, which takes us in the direction of implementability. Because excess explanatory baggage would be theoretical baggage of the theories about what are the internal properties of the cause. So in the course of history, you had new experiments and, of course, new descriptions. So scientists like Hitler, Goldstein, and others who use different cathode tubes, but similar, essentially similar to the ones used by Brugger. And so they added the predicates observed properties of the experimental setup. So what was identified previously by Brugger, imperfectly satisfied, was partially satisfied of the new descriptions that were provided on the course of history, on the basis of new experiments and new apparatuses that were similar to the original cathode tubes. And the cause of phenomena remains an imperfect satisfier of successive descriptions. So the reference was stable, fixed in a stable way through changes of discoveries, experimental discoveries. Okay. But then Thomson identified some intrinsic properties of the cause, because of course scientists will not rest on them with a mere description of some X, which is the cause of some specific phenomenon. The scientists want to know what is the cause, and to tell what is the cause, they must find out some intrinsic properties of the cause, and those intrinsic properties, of course, are not directly observed properties. And these are the properties that the scientific realists want to make a case in favor of belief in them. But of course, Thomson was talking about the same thing. These intrinsic properties are those possessed by what Brugger and others have previously described and explicitly identified as the cause of the specific effects observed under the same or similar, very similar experimental conditions. So, even though Brugger's description and others was not an intrinsic description, the reference was not an indeterminate X. There were detailed descriptions of the conditions for repeatedly observed specific effects. And of course, the stability of the reference is obtained by the variations of the names used, like cathode rays, low rays, and other descriptions that mention possible explanatory properties. But so such explanatory properties are not present in explicit closer descriptions. This allows, Thomson, as I said, to claim that the ratio mass to charge is a property of wax, Ricker and others previously identified. Okay. And obviously the terms in the descriptions were understood by all scientists participating in the debates on the intrinsic nature of the goods of phenomena observed in the strike tubes. The Thomson determined that the ME value is very small, so they can do atoms or molecules whose ratio is much higher. So Thomson speaks of the electron is the term which is introduced by Thomas. And the terms charge and mass was, of course, understood by all scientists. So in this case, there is no semantic increment. Pselos disagrees. Pselos claims that it's not enough to have an extrinsic description. You also need intrinsic properties to identify what the scientists are talking about. So the identification, according to Pselos, of an observed reference can only be achieved by a description mentioning some intrinsic properties, the attribution of which is justified by explanatory requirements. So in this case, the success of reference depends on some theoretical context, and here there's the threat of incommensurability. And Pselos adds, since there is no theory independent way to identify the causal origin of phenomena, what bears the burden of reference is these causal explanatory descriptions of the kind of associative properties. Of course, Pselos wants to counter the incommensurability objection, and he, in a typical scientific realist move that we discussed today, he says, well, then if we can show that the properties, the observed properties play a causal explanatory role, then we have good reasons in the existence of the reference identified by these internal properties which do play a causal explanatory role. However, there are problems with this kind of move, but that as well. But if we resort to Nola's causal explicit description, this account of the notation, then we dodge the problem raised by explanatory descriptions and the threat of incommensurability. So we do not have to identify a stable referent to resort to what Pselos calls central. Central causal descriptions. Now there is a problem. All this is well fine when you stick to electric discharge tubes, but then when you move to other experimental, very different setups, how can you secure the identification of the reference? You can secure the identification of the reference according to explicit descriptions. Why if you stick with the class of experimental setups, namely discharge tubes? When you move to other experimental setups, then there is no other way than refer that then including in your description extrinsic properties. So you must resort to intrinsic properties, which hopefully remain invariant through the various methods of observation and measurement in different experimental steps. So that's which is specified scientific. And then the scientific realist must provide an argumentation in favor of the reality of these intrinsic properties, namely, in the case of the electron, the specific value of the M2E mass to charge ratio. So how do you do that? You do that, according to me, by inductive methods. I explained briefly at the beginning of the paper, by means of the four conditions. So according to me, mass and charge are observable properties. I think it's indisputable. I can defend that, but I want to do that now. And make so make a case for the existence of this mass to charge ratio by means of the four Gaussian conditions: validity, causality, invariance of measurements. Now, but let's look now at another experimental setup and some radioactive materials used as a source of beta rays in star tubes. Similar luminous phenomena are observed, and they're measured if the ratio remains very small. So this value is sufficient to support the photon fusion. And quantum mechanics and relativity state M2E ratio to electrons at rest. So the identification of reference has a robustness with respect to theory changes so far as some of its intrinsic properties remain unchanged. So quickly, an illustrative episode of the history of physics. At the beginning of the 20th century, scientists tried to discover the law of variation of the ME electron ratio with velocity. And there were two competing theories. There was first Lorentz theory: the electron is deformable. The variation of its mass with velocity is accounted by special relativity. And the competing theory is Abraham's theory of the rigid electron. And Kaufman's measurements initially showed that they agreed more with the theory proposed by Abraham, theory of the rigid electron. So there was a competition between two theories here. Obviously, there was no threat of incommensurability in this case, because the identification was not problematic, since measurements have to do with the detection of beta rays in electromagnetic fields. Einstein's and Abraham's computing theories had to do with different meanings to the term electron. That's relative meanings, theories, the properties, intrinsic properties attributed to electrons. But discussions did not focus on meanings, but how experimental devices work, the sources of error, and everything, because the reference wasn't sufficiently identified and satisfied partial descriptions, or the partial descriptions of the notation. And finally, accurate measurements confirmed special relativity, so special relativity 1, as you know. So, this competition between theories could not have been resolved if electrons had not been unambiguously identified by all participants. Conclusion. There are several claims that I try to substantiate here. So the identification of reference, and I took the example of the electron, I must make clear that history of science is not a substitute for philosophical arguments. There are taken to be illustrations of cases in which the philosopher can show that there is an elaboration, some philosophical arguments, strong arguments in favor of the existence of some properties. So the identification of reference is first, in the first place, ensured by a description of the intrinsic property of being the cause of specific phenomena, which are described by the properties. Reference of terms are electron, G, molecules, layers that are imperfect satisfiers of extrinsic descriptions proposed. Denotational refinements, for example, hydrogen isotopes, or the gold observed by the Spanish explorers, two kinds of gold, genuine gold, fool's gold, also take place. It's possible that we will discover that there are two kinds of gold. It's not excluded. So there has been changes in the meanings of expressions taking the same reference, but this does not imply that proponents of different theories about intrinsic properties do not understand each other. Some intrinsic properties, which is justified by the four conditions, or six conditions I mentioned, they manifest remarkable stability. Electron is in point, and for those who are curious to see the arguments to be detailed, a detailed version of these arguments, there is a book forthcoming, my book, Scientific Realism, Laws of Nature, and Physics of Powers, forthcoming in this library. So I think I understand the basis, neo-Aristotle basis, but without this. Okay, thank you.